Good morning, everyone. I'd like to welcome the next speaker, which is Bashir. Unfortunately, there was a very last-minute change, and he wasn't able to travel to Minneapolis, so therefore we arranged a virtual presentation. You just saw him just for now, but he had to turn off his camera due to CPU usage of the machine. I hope you understand. And, well, Bashir, maybe you can turn on your microphone. Oh, there you are. I wish you a good presentation.
Thank you. Thanks for the introduction, and thanks everyone for coming. Yeah, I apologize that I have to do this remotely. So yeah, on Sunday I was denied entry to US, which was strange after over 10 years of being a Canadian citizen and coming to US very often, including 6 months ago for Global Digital Health Forum in Washington. Anyway, it seems that Uncle Sam doesn't want me in US, so I have to do this remotely, and then I may also turn off my camera just to make sure that my 90% plus CPU usage is a little bit lower and it doesn't die during the presentation. Okay, yeah, like I said, I am Bashir Sadjad. I am a software engineer at Google. I have been in Google for the last 14 years. I guess the first half was mostly around data engineering and ML models for display ads. And the second half have been around healthcare data, especially since 2020, where I have been working on digital healthcare systems in low resource environments. Our team is Open Health Stack. So we have 3 main components, all of which are open source, and all of them are actually designed for the low resource environments. So very quickly, the first 2 are not the topic of this talk, but I like just to mention Android FHIR SDK is a set of libraries to develop FHIR first applications for Android apps. And Jing from my team is actually present at DevDays, and if you are interested, please talk to him. We also have like a set of pipelines and some tools for doing analytics on FHIR, which is this FHIR Data Pipes project. I have been working on this for a few years, and Chandra from my team is also in DevDays, and he knows a lot about this module as well. And then the topic of this talk is the information gateway, which I'm basically going to talk about it in the next few slides. Okay, so what's the problem statement? So the problem statement is that we have like a separate app, like a mobile app or a web app that wants to access FHIR data in a FHIR store, in a FHIR server. I mean, it could be for different purposes. I mean, one common use case that we need to deal with is like community health workers, for example, working in remote villages, and they want to have an offline app. But then, when they are online, they want to be able to, connect to the FHIR server, sync resources, and then access if there are new resources for their patients and so on. But this problem can be many other cases as well. Like it could be like a web app for a program admin. It could be like a patient app that the patients want to access their own data. And also, like, it could be like, backend components, but that piece is out of the scope for this talk. So I'm not going to talk about that because there's a difference there. So it's mostly about, apps, user-facing apps. And the gateway, if I want to summarize this in just one sentence, is just like another, like a FHIR shell around the FHIR server, which basically, so it is where people implement their access control logic. So the goal is that, we decouple the access control logic from the actual FHIR server. But this gateway understands FHIR, so it can process incoming FHIR API requests, and it can send them to the backend FHIR store after applying, access control rules. So the main design principles that we have had when designing this gateway is that we wanted the access control to be flexible, and it should be easy for people to actually, change the access control. So it has a pluggable architecture. We don't want to put any trust on the app. So it's all about access tokens. Whoever has the access token, we assume that, like malicious intent. And, but, the token basically defines what the user has access to. And also we want our design to be generalizable, meaning that it's not tied to any specific FHIR implementation. It should just work through the API. So yeah, the next slide. Yeah. So also it's good to separate these concepts because it's important for the architecture that we have. So authentication basically is knowing who the user is. Authorization is the question of what that specific user, like Bashir at google.com, what he has access to. And then access control is to apply those authorization rules basically on the request and whether accept or reject request. Everything that I talk about here is built on top of OAuth. I won't be able to get into too much details. I assume that some basic knowledge of OAuth. Maybe this is just like a terminology slide that I just put there, and you can access the slides later if you want. Then the first two concepts is probably good to remind people. So in the context that we are talking about here, we are mostly talking about public clients. Versus like there is no client secret basically, and that's actually one reason that I put the backend systems out of the scope for this stuff. So there is no backend component here. So there is a mobile app or a web app, and everything is just through this. The token is actually the actual access token is shared with the app, and the access tokens are mostly JWTs. I mean, it can be like an opaque access token as well, but in the scope of our work, we always work with JWTs, like JSON Web Tokens. Okay, now, okay, so then what's the architecture? The architecture is basically, we have an authentication server and we have an authorization server. These two can be together or could be separate services, but we don't exactly care how that part is done. Some people use like a key clock server, for example, to have both of them together. They may use a generic identity provider service like Google or GitHub or whatever to solve the authentication problem, and then the authorization is a different server. But the focus of our work is the gateway. So after people have an access token, they use that access token to request resources from the FHIR server, update resources or fetch resources, basically. And that's where we get the access token and we can talk to the authorization server, the FHIR gateway, and we receive the request with an access token attached to them. And then we apply the rules, the access control rules on the incoming FHIR API requests. And then basically we push them to the FHIR server for responses. Now the actual ACL, where the access control rules are could be a separate database. That's again out of the scope. The gateway, a plugin may actually choose to talk to a separate database. Again, that's the choice of the access control plugin. Or it actually, the access rules might have been implemented inside the FHIR store itself. For example, it might be based on location resources or organization resources, for example, or care team and things like that. Or the general practitioner of a patient, if it matches the user that is currently accessing using the app, then we may let the user access and things like that. So there are different options for implementing where the ACLs are. The other thing is that the core FHIR gateway, the core of it is stateless. So if the plugins don't make it stateful, it's basically the core is stateless, and then it makes it very easy to scale it. And then we basically release like a Docker image, which is very easy to deploy that way. Okay, so the main access control strategies that we have envisioned when we were designing and implementing the FHIR gateway are the following four. So probably the most important one is that we have, our idea was that in many cases, the access is around a patient. So patient is a good building block for building access control rules. What I mean by that is that either the user has access to a patient or they don't. It could be the same patient. It could be like a practitioner may have access to a set of patients, but patient is the building block. Because of that, we have implemented libraries to make it easy to apply patient-based access rules. Like the most common one is like a single patient app, which I'm going to talk about a little bit later. Another category is query templates, which you can block a specific query template or grant access for a specific query template. I mean, one example for those that you need to grant access is these get pages for FHIR. So if your backend is FHIR, you want to configure the gateway saying that any get pages request should come in. And the reason for this is that the original search criteria that created this pagination is not accompanying the URL, the get pages URL. So at the time that we receive the get pages request, we don't know the context of this search result. Remember that the gateway is completely separate from the actual FHIR server implementation. Another example that we block in some of our sample AccessChecker plugins are different types of joins. Like chaining, reverse chaining, include, rev include, and the reason for this is that it makes it much harder to apply the access logic at just by inspecting the URL when you have chaining. And one particular example that I usually use is that, let's say HIV status of the patient is a sensitive information that you don't want to use to share with a specific user, like a practitioner. And you filter out observations that have HIV status. But if you have like reverse chaining, you can basically find out the HIV status of a patient by a reverse chaining search query on the patient. So you are just searching for a patient who is yours, but you can figure out their HIV status, for example. Another category is query rewrite, which basically we use for adding, URL parameters, limiting the scope or adding labels and things like that. And finally, it's post-processing, which, when the results come back, you can actually post-process and work on it. This is the interface for an AccessChecker plugin, which basically is what I said. So I skipped this one. And yeah, so basically the structure of the gateway, it's basically like a FHIR server. So it's basically like a FHIR plain server. That's how it is being implemented. So we heavily rely on FHIR libraries for processing, FHIR requests and things like that. But then, when the access is granted, the request is basically proxied to the actual FHIR server. And yeah, it does things like token validations and advertising well-knowns and things like that. There are, as I said, there are functions for patient to handle patient scopes and patient compartment and things like that. And there are actually two sample AccessChecker plugins that are available out of the box. One is like a SMART-on-FHIR, like if you have a SMART-on-FHIR, like a standalone SMART-on-FHIR patient app, like growth chart, for example. It can just work out of the box. You can just set the plugin to be that one, the AccessChecker plugin, and then your app should work out of the box. And another example, which is very common for our CHW use cases, community health worker use cases, is the when a user has access to a list of patients. That's also a common example, which we have included as an out-of-the-box AccessChecker example. So I'm going to skip these query examples, and if there are questions, and we can later go through them. By the way, I will also answer the WHOA questions afterwards. So unfortunately, I am not there to talk to you folks after. If there are questions, I would go through all the questions that are posted there. But I can come back to this slide if there are questions about this. I want to spend a few minutes, maybe 2 minutes, on this real-world example. Like I said, everything that we do is open source. But we rely on our partners, on like implementers, basically, to deploy the components that we create as part of Open Health Stack. And one of the examples for this FHIR Gateway is this community health worker app developed by ONA, which is called OpenSRP. So the new version actually uses the FHIR Gateway as the basic, one of the basic components to do access control. So they have implemented their own AccessChecker plugin, which is based on roles. So they have the different roles, and each role has access to certain resources. One other thing that they do with the FHIR Gateway is that, so there is an option to create custom endpoints. So if you, and one example of this is like sync your patient data. So let's say a community health worker has access to a certain set of patients, and then every morning that you want to sync all the data that you have for your patients. So basically, you just make one endpoint call, and then at the backend side, you implement like many backend calls to the FHIR store to basically to answer that custom endpoint. And this is something that ONO has done with the kit. Okay, so let me finish by just saying that, well, first of all, thank you for coming. Please get involved in the work that we do for Open Health Stack. Like I said, everything that we do is open source. Not only the code is open source, but our development process is also open. So everything happens on GitHub. We have bi-weekly developer calls on Thursdays. And these are some of the planned features that we have for the FHIR Gateway, like audit events, security labels, and things like that. So I'm going to turn on my camera as well. My browser didn't die, which is a good thing. Yeah. And I would be happy to have questions.
Thank you, Bashir. Are there any questions? Yeah. And if you turn back and look into the camera, then Bashir can even see you.
Hi. Are there like challenges when you search a FHIR server? The search set result has a lot of internally consistent links, like the next page or something, or self. Do those present like a lot of problems with the proxy?
Right, that's actually an excellent question. And so actually one of the things that the core FHIR Gateway itself does is exactly that thing. So there is like a post-processing stage where everything that is received from the FHIR store, so all of the URLs are parsed and they are replaced by the gateway. So basically, so if I go back to this slide that I was showing so yeah, this one is actually a good one. So basically, the interface to your FHIR data is the gateway, and the existence of the actual FHIR store is completely hidden. So yeah, the URL needs to be translated, as you said, and that happens in a post-processing in the FHIR gateway.
Sorry, according to Gino's talk earlier today for the FHIR Search API, the next link specifically is opaque, and you can't really assume that you know anything about what it means outside of the server. So I don't know.
That's also a good point. So what we replace is the actual, like the host. So let's say if the host part is I don't know, happy.fhir.myorg.com, then the URL for the domain for the gateway is fhir.gateway.myorganization.com. So all that we do is that we replace the domain part, and everything else we keep the same. Now, when the next query comes in, then we need to actually do the opposite, basically, and then translate that to go from the gateway URL to the FHIR server again. So basically, we just hide the presence of the FHIR store. I hope this is clear. So it's only at the domain level, and then the rest could be opaque. Exactly.
We have another question.
Thank you, Bashir. Wonderful talk. So in the presentation you have, the proxy would be able to redact sensitive attributes from within a resource. Is that something need to be implemented at the plugin level, because the role-based access control is going to be mapped to the specific resources, which obviously the proxy would not understand. So is that to be built into the plugin?
Exactly, yeah, and that's also a great point. Like, I mean, for the sensitive, like HIV status, for example, that's actually an example that needs to be done at post-processing. So basically, there are three functions that plugin needs to implement. One is can access, basically, should I grant access to this request? The other one is to mutate the request. So maybe we want to say, yeah, I can I can add, like, let's say a slash observation, I would say, yes, I accept that, but I only return the observations for that specific patient who you have access to. And then the last part is the post-processing. So the gateway gets a chance, the plugin gets a chance at the end to inspect everything that is going to be sent back to the user and then make any changes that they want to. Thank you.
Yeah, 2 more questions.
Thanks.
So if you're replacing the host name, how do you know where the next link, like how do you know how to replace it back on the other end? Like how do you know which bundle the next link is for if you're not generating your own next link?
So basically, let's say I have, let's say FHIR.store / opaque link, right, for my next link or for any session. Then when I receive this from the FHIR store, I replace it with FHIR.gateway / opaque link. Now, when I receive that query back, like, I mean, this get pages is actually a good example. I mean, it's exactly basically what is happening. So for FHIR, there's a get pages query, and that's completely opaque. So that's just one number. So we have no idea what this query was for. So we give the option to the user saying that, any get pages, just let it go. I mean, I know there is like a security issue here, and I mean, for some other FHIR servers, you don't have this problem because beside the opaque link, you also have the data about what the original search query was. But let's say it's just like opaque link. When the query comes back saying that FHIR.gateway / get pages, whatever, we just replace FHIR.gateway with FHIR.store with the same / get pages, and then send it back to the FHIR or to the FHIR backend FHIR server. So you see, I can always do this back and forth. I mean, on the way out, put FHIR.gateway. On the way in, replace FHIR.gateway with FHIR store.
Okay, Bashir, we have one more question from Vadim.
Thanks, Bashir.
Perfect, thank you.
I'm wondering, can FHIR Gateway also support non-FHIR backends? If, let's say, I want to store my user management or user settings, there's no need to be stored of that in the FHIR server. So could I have custom ACLs for my non-FHIR store as well?
Yes, exactly. Yeah, and there is option to add like custom API calls, but again, that completely falls within the scope of the plugin. So the things that happen in the core function that we have implemented, it's all about FHIR API, and we understand FHIR API. But if the plugin chooses to have custom endpoints, like the ONA example, for example, it's absolutely doable.
Okay, thank you. These are all the questions. Should you have any more questions, please post them in the Hoover, and then Bashir will get to it. Bashir, thank you very much. Big applause for him.
Thank you. Thanks.
And see you later during the event.